you will see that universe need not expand like this because of some other effect. We have not seen it. Yes. Sorry?
Is the rate of expansion is a constant value?
Oh, no. We there are cosmological parameters for that. Again, we cannot estimate the expansion rate for the universe, which you are because when you observe, you are actually observing at a farther point, and you are getting an information which is coming at a farther point in time. So your estimation of expansion is definitely not the expansion at this moment. Okay. So still you can model. You can model at different directions and see how this expansion is happening. So we so far we do not see any difference from one direction to the other. So we see galaxies in this direction and or in this direction. It's somewhat symmetric. So no, that is a projection. Okay. Because how will you represent a three-dimensional data into a two-dimensional plane? So that point and this point are not, they are same. If you flip it to, you can think of this like if you make it a globe by flipping all sides. So the top bottom is actually the same. This end is actually the same because then otherwise you cannot represent in a page, right? There. So imagine this is spread into a inside of a sphere. There is a spherical surface. So you just make it. I mean that is why. So it is not a linear, singular one. So you just these 2 points are same. These 2 points are same. These 2 points are same, and there is matching.
Yeah. So our other speaker is also there.
Hi.
So we have to close this session because this session after that the other person conclusion. So I thank Kaushia and being with us. He's always friendly, just with a call. And he spends so good time. And one more thing is that first time, no, I remember first time I kept the long 2000. First time when I called him for a talk, he said, "Who are the audience?" At that time, how do I do this? He tried to elaborate. No, this one, he was always in academics. He never gave anything popular talks. Now I think okay. So anyway, I thank you and I close this particular session officially, and you can just let it down and introduce you. Start this. So next we have with us Mr. Arvind Panashwe, who is the director of Nehru Planetarium, and he has also been in a lot of our regional science centers, planetarium science program, and he gives frequently talks, not only here, everywhere. So I just see he is by profession, he loves astronomy, and he has been working in various of the astronomical projects. For example, he worked in our lake, and he was involved in research of minor bodies in the solar system. And he and his team has found out an asteroid called 4130 Ramanujan. And again, one more asteroid, 1717446 Mopaku. That is a name with first 2 alphabets, matching with the 3 persons in the group like Murthy, Arvind Panashwai, and Kamachakan Kukuson. So this was in January 23, 1990. And he was recently awarded in 2023 the Ajit Zubin Kimbagwe Award for Public Outreach and Education in Astronomy by Astronomical Society of India. And he also got a medal for discovery of asteroid, and he is very much involved in popularization of astronomy at present. So I welcome you, and he will be speaking on minor bodies, asteroids and minor bodies.
Thank you so much, Jayendri. And good evening to all of you. It is just that I was listening to the discussion very carefully and I was enjoying it. And I'm really very sorry to break into it. But the thing is that I need to go by about another half an hour's time. So let me quickly go through my presentation, and maybe at some other time I can spend a long period of it. There are certain constraints which I have to go through. So maybe without further talk, let me start with sharing my video or the PowerPoint presentation. So here we go, and I hope it comes up. We tried it and it did work. Slideshow review. Then let's see. Is it on screen now?
No, it is not.
Can you see?
No, it is not there. You just press that arrow. In bottom one, upside arrow is there. Upside arrow.
Yeah, you actually showed me some time back.
Yeah. Bottom one there is an upside arrow. That you press it, then it will present.
Okay.
Share.
Where?
You have to share your screen.
Yeah, I'm sharing the screen.
Yeah. And full window you share it. Yes.
Yeah. Okay.
And full screen you make it.
I'll make it full screen.
Yes. Okay.
Okay, friends. So, in the next 25-30 minutes or so, I'll talk to you about eclipses, occultation, transits, etc. And there are very fantastic astronomical phenomena which you would always enjoy watching this. Okay, so let me start by telling you that this phenomena actually involves the three astronomical bodies, at least two astronomical bodies, certainly. But if there are three astronomical bodies, then you will see that phenomena is slightly different. And then why two astronomical bodies? Because of eclipses. So I will come to that. Okay. And these phenomena are observer dependent phenomena. That is, it based on where the observer is. And if you are an observer, then your location is important in this case to see the phenomena. If you are not located at proper place, then you will not see the phenomena. For example, if there is a total solar eclipse or a total solar eclipse which is taking place, sorry, over your location, then you will see it. But if you are outside that location, you will not see the phenomena of total solar eclipse. That is what we mean by this. Okay. So what is called the occultation, transit, eclipses is what I am going to explain to you first by some diagram. What I am doing is that I have taken Jupiter as an example, moon and moons of Jupiter and Jupiter as an example to show you this different phenomena, what we mean by occultation, eclipses and transits. So imagine that this is Jupiter here, which if you can see here, this is a Jupiter and there are 4 moons of Jupiter which can be seen. Now these moons of Jupiter are called the Galilean moons because in 1609 say and 1610, Galileo Galilei first time saw these moons, and actually he used this particular his observations to prove in support of Copernican theory that the sun is at the center of the solar system and Earth and other planets are going around it. So now this is what it looks, but suppose if you look at this thing from up like this, so then you have Jupiter here, and instead of taking 4 satellites, I have taken only 2. So this is 1 and 2. This is outer satellite and this is inner satellite. Okay. Now look at this. The sun rays are coming from this direction. With the same picture, I have removed Jupiter from here. The sun rays are coming from the same direction, and this is the direction to observer. That is, you are located somewhere here, and sunlight is falling on Jupiter like this, and you are located in this region. Now, what can happen is that when you look at Jupiter from this location, what you will see is that Jupiter is here, and now you can see to its left these 2 moons. So the picture would appear like this. In earlier side, when you saw the moon side by side, you saw them side by side only because of perspective of your observer's location. So let's see. When the sun rays are coming, so all these bodies, this moon and Jupiter, naturally they will cast a shadow. Okay, so this is the shadow of one of the outer moons of Jupiter. Okay, and then as the time progresses, this moon which is in the inner orbit actually would come inside the shadow of Jupiter. Looking it from the side, from Earth, what you will see is then the bright Jupiter, then the outer moon, and somewhere if you have a large enough telescope, then maybe you can see a very faint inner moon. Okay, normally with a small telescope and all that, we do not even see it, actually appears to vanish, but that position is there. Now, this event or this observation is called eclipse. So basically, understand that when one body casts a shadow on the other body, and the other body does not, that you cannot see the other body, then such a phenomena is called the eclipse. Okay, I'm so sorry. The other thing that can happen, that the inner satellite is moving and outer satellite is also moving. So situation can come where the outer satellite can directly come between the inner body and the observer. You see, this body is hiding, so you can see this green fellow is completely blocking the blue fellow, and such event is called occultation. Okay, this event is called. So once again what we understand is that if the farther body is blocked by the body which is closer to us, okay, and it's completely blocked, then such an event is called the occultation. Now eclipse can also be like this, when we said that not necessarily that outer body should cast its shadow on the inner body. Inner body also can cast shadow on the outer body. So you can have an eclipse actually like this, and what you can see is it's exactly like this. That is, now you see in your perspective, this inner body is closer to Jupiter and outer body is far away. So such a thing also is possible and can happen, and it is still will be eclipse. Or these both bodies can come inside the shadow of this big planet Jupiter. So this is all the eclipses. Okay. Now something very interesting can happen, and that is that smaller body can come between you, or that is observer, and a body which is far away. Okay, and then as you can see here in picture that there is a body which is far away, that is the outermost outer satellite. Then this inner satellite has come directly between Jupiter and us, and then because the angular size of inner body is much too smaller than Jupiter, so this particular body is seen as if it is traveling across the disk of the Jupiter. Now this phenomena is called transit. So in transit what happens is that the closer body does not block the farther body because its angular size is small and it is seen traveling across, and this is called transit. So now let us recapture everything. that the difference between occultation and transit is that in occultation, angular size of the body near the observer is bigger than the one that is behind. And the angular size of the body near the observer is smaller than the body which is far behind, which is behind. So remember, these are the definitions of occultation, transits, eclipses, and so on, which we shall be discussing in as the time goes on. Okay. So, but we can always say that when we have a solar eclipse, so a solar eclipse is actually occultation of the sun by the moon. Now we still continue to call eclipses because over a period of time we have been discussing this as a eclipses only. So we still call it eclipse and not occultation. Similarly, sometimes when the sun is closer to Earth and the moon is little far away, the angular size of moon can become smaller and it can block the sun completely, and in such a case it is called the transit of moon over solar disk. Okay, and again we call this as it is called the annular eclipse of the sun. Annular because it leaves a ring behind, as you see here, it leaves a ring behind. So friends, let me also tell you why this is called eclipses. That eclipses term has come from a very interesting point, and that is that path of the earth or the path of the sun on the celestial sphere as seen from earth, it is called ecliptic, and all the eclipses take place on the ecliptic. So eclipses take place on ecliptic, and then it are called the eclipses. Okay. Now, very quickly, I'll summarize. I'm told that lunar and solar eclipses have been discussed, but just for the complete sense, once again, I will repeat it out. When the Earth casts its shadow on the moon, causing the moon to go dark, then this is lunar eclipse, and that takes place only during it happens only during the full moon period. And otherwise, when the solar eclipse takes place, when the moon casts shadow on Earth, causing the sun to go dark. Okay, and the moon comes in between the thing, and this happens during the new moon period. Now comes the question: why do we not have lunar or solar eclipse on every full moon day or new moon day? And that is because the orbit of moon is inclined to the orbit of the Earth, which I suppose has been discussed. And this is what it is. So this is the orbit of Earth around the sun, and this is the orbit of moon around the Earth, and this is how the shadows will be casted here. So in this case, you have the solar eclipse, and people standing here would see the solar eclipse, and all people in this part of the world will be seeing lunar eclipse. So now remember, there is a small interesting fact of this, is that lunar eclipse can be seen if you see the lunar eclipse is going on, and if the moon is visible on your horizon, then it is a lunar eclipse you can see. Excuse me. But to see the solar eclipse, you will have to go into the track of the solar eclipse. Now you see here, the another situation is that even though this is of course this is a very exaggerated image or exaggerated drawing, but even though this place shows that it's a new moon and full moon and new moon period, but because the orbits are inclined, we do not see the eclipses. So that is the reason, and here this particular diagram sums it up all together. Okay, so now here you see the lunar orbit which is shown, and this is the narrow track on which the solar eclipse can be seen, and all other places you cannot see the solar eclipse. In fact, if you see in the just outside the track, what you will see is the partial solar eclipse, and places other than that you don't even see the solar eclipse of any kind. And this is a beautiful picture which is taken on August 11, 1999 of shadow of moon on the surface of Earth. Okay, so this is how the progress of solar eclipse takes place. I am not going to go much in detail as it has already been discussed, but this is how a partial solar eclipse looks. And then this is the when during the total solar eclipse, moon starts covering the sun step by step, and that is what I am going to show you, so that it is covering, and it is an amazing phenomena. On 8th of April this year, there will be a total solar eclipse which will be seen from America. If any one of you are keen and interested, you should go and see the eclipse. It's a beautiful thing. Okay, but what happens is that as the moon progresses its journey over the solar disk, it becomes thin and thin and thin, and then it becomes so thin. At that point in time, it casts what is called the shadow band. This is one of the very earliest sketch of what is called the shadow band. Shadow band is where the eclipses take place. I mean, what happens is that if you see on the surface of this is the cloth which is being put, and you see the shadow band, and the reason is very similar to what you see inside the pool of the swimming pool. Okay, bottom of the swimming pool. That there are a lot of atmosphere has a lot of turbulences, and when the sunlight, thin sunlight, when it passes through, it creates a effect of shadow band. Okay, so something interesting I would like to tell you is that someone took the picture of, I'm sorry, so as the moon covers the sun for a very short period, what you see is what is called the prominences. Okay, and this is the upper region of the sun, and which is giving very bright light. So if you see, take a spectrum of the sun in the normal case, you will see the white broad spectrum with lot of shadow, with the black lines which are the solar lines. Okay, but if you take a spectrum like this, now you see various lines. Okay, and at one point in time, most of the lines you could identify, but some people could not identify one particular line, which is here, which is called the helium line, which we have got to know. If it is covered, well and good, but this particular line, which was seen for the first time in the solar spectrum, and people did not know what that line is due to, and this was called the helium. Okay, a lot of arrows were drawn, but let me go ahead and come to some very interesting aspects of this. After the what is called the flash spectrum, now we have the diamond ring phenomenon. Looks amazing at the beginning of the eclipse and towards the end of the eclipse. So it's worth looking at it. Now, two things to remember about solar corona is that when the moon completely covers the sun, you see the solar corona. Sometimes it is very symmetrical, and when you have large number of sunspots, then what you see is that sunspot take place, play their own role, and then you see the sun corona being stretched on the other side. So during this solar eclipses, even if you don't go to USA, remember that when you see the pictures of the solar corona taken during the solar eclipses, it will be stretched on the other two side because there are a lot of sunspots on them. Now this particular diagram shows the annular phenomena of the total solar eclipse. Okay, basically the sun progresses, moon progresses like this, and annular thing was left. In fact, some of you might remember that in some years ago, on 15th of January, there was a total. There were two annular eclipses which took place from the southern part of India, and I remember me going to Kanyakumari to see this event. Anyway, so this goes out like this. Now let us talk about the moon. So moon goes to the shadow. Now I will quickly run the thing because we need to talk about the occultations also. So I will quickly run. Now this is the outer shadow, is a penumbral shadow. Inside is the umbral shadow, and as the moon moves through the shadow, what happens is that part of the moon gets covered by the shadow of Earth, and when it passes through close, then you see the moon, which is reddish in color, and that the reason for it is nothing. It's exactly the same as why the rising moon or sun, which appears reddish in color. What happens is simply as follows: that when the sunrays goes through the atmosphere of the Earth, the blue region or blue wavelengths are scattered away. There is short wavelength, they are scattered away. There is a red long wavelength. They continue to proceed, and In case if Earth had no atmosphere, then Moon would have been completely dark. We wouldn't have seen the Moon during the total lunar eclipse. But here, the red portion of the Sun spectrum falls on the Moon, and you see the lunar eclipse. And it's a beautiful thing to watch when the Moon is covered by during the totality covered inside the shadow of the Earth. Now, here is a very interesting story, and which has happened, and which is used by Christopher Columbus. He was marooned, and his ship had some problem, and at Sundance Bay in Jamaica, and he was marooned there. And for some reason, the local people had stopped giving him support, and then we realized that there is going to be a total lunar eclipse which will take place on 29th of February 1504. Another exactly, you can see that it was also a leap year, 29th of February. So what he did was, he told the locals that if you do not continue to support me and my crew, then what I will do is I have a direct connection with the God, and I will take away your moon. And actually it did happen. As the eclipse progressed, the moon got covered by the shadow of the earth, and it became darker and darker, and actually moon for a while it appeared to have vanished. And when it vanished, the locals realized that this man has some kind of a godly power, and they came back and told him that yes, you can, we will please restore our moon, and we will give you the supply. Now, two things here we have to remember is, or rather we should realize is, that at that point in 1504 in Jamaica, people were still native enough not to understand what the eclipses are, whereas in the western and north side of the world, where people have already studied, understood the eclipses, and they were predicting it. So you can see that there's a vast difference. Not it is just few hundred years ago. There was such a vast difference between two societies. One is in Jamaica across the big sea, and where people had no idea what the eclipses are. And here you have humanity, which not only knew what eclipses are, but they had developed a powerful mathematical tool to find out when the eclipses will take place. Of course, then Chinese had the Dragonity moon and so on. Now, let us take one example of how occultations and eclipses and transits have helped us to understand the solar system. You see, by 1700, the heliocentric model, that is model proposed by Copernicus, in which he says, just as I said in the beginning, this sun is at the center of the solar system and planets are going around the sun. So that was the heliocentric model was. And they knew by some method, I won't go into that method, but it's a Keplerian law. They knew how distance from Earth to the Sun, distance of various planets from the Sun in terms of Earth-Sun distance. And Earth-Sun distance, what we call as an astronomical unit. Now this is what it is. If you consider Earth-Sun distance to be equal to 1, then Mercury is about 40% distance between the Sun and Earth. Venus is something like 70%, Mars is outside by 1.5 times, and so on. Okay, so you knew how the planets are placed in terms of Earth-Sun distance, but you didn't know that how to get that particular value. Now today we have different methods, but if you see about 1700 and 1800s, there was no way they could find out the actual true value of one astronomical unit. And then in 1716, Edmund Halley, who we know as a discoverer, who talked about a comet, that comet come repeatedly, and they travel across, they come from far away distances, go around the sun and go back, and they are nothing very different than the other planets are. So he is famous for Halley's comet. But Edmund Halley was a phenomenal person. Unfortunately, he does not get as much credit or publicity as his very close and dear friend Isaac Newton. We remember Isaac Newton for his contribution, and Halley's contribution also was phenomenal. He also talked about the magnetic compass and plotting the star maps and so on and so forth. So he was an amazing person. In fact, Edward Halley supported Isaac Newton in publishing his Principia. Anyway, that's a different story. Now, just imagine here is the sun and this is Earth. Okay, and Venus is placed in between. Now, I'm going to show you that in this case, if you are observing from Earth, then what you will see is a transit of Venus across the solar disk. Just imagine that you are standing here and the Venus is coming to transit across the disk of the sun. Okay, now what Edmund Halley suggested was that consider 2 points on the surface of Earth, point A and point B. Now, people on point A would see Venus somewhere here projected on the solar disk, whereas people on point B would see the Venus projected on the solar disk somewhere here. And of course, if you are in the middle at somewhere here, you will see at this point. So what Edward Halley said that go and observe the transit of Venus. Okay, and what you will see is that A will see the track of Venus on the solar disk going like this, and the observer B will see the track of the Venus across the solar system like this. Okay, so now what we have is that we have angular diameter of the sun, which can be measured very clearly, and then we have two tracks. So if you know the diameter of the Earth, angular diameter of the moon, and also from that angular diameter you can find out what is the angular separation between A dash and B dash. And then using a very simple trigonometric relationship, you can find out the distance to the Venus from the sun. Now, unfortunately, this method proved somewhat impractical even then. But remember, this to find the distance to the sun was such a great event that at that time the transit of Venus was observed. Many countries they sent their people to go and to different places to find to observe the transit of eclipse, so that the distance between Earth and the sun can be found out. And what they had done was, interestingly, that governments had given special flags to their ships so that these ships will not be, because remember at that time England and French were they were warring states, and their ships were fought in the middle of the ocean. Okay, so sorry. So this is how it was done. Now you remember that if you know this angle is this. A, V and B is one angle, or B prime, V, A prime is another angle. Now you know this angle, you also know this distance between Sun and Venus. So once you know this angle, you can actually calculate what should be the distance between the two. And then you know that this is 70%, so you know how much it will be from this place. So that is how they made the first attempt to find out the distance between the Earth and the Sun. And of course, now there are many different ways to do that. Okay. Now, something interesting about eclipses, solar eclipse. Let me talk to you about that. Newton actually asked this question, that can the rays of light be bent by the sun or by the gravity? You know that Isaac Newton talked about the gravity. So, he gave the formula. But Newton also asked that can gravity itself bend the light, and this final answer came out only after Albert Einstein who talked about it. So what question he asked is that, do not bodies act upon light at a distance, and by their action bend its rays? And it is not the action, that is, he talks about the strongest and the least distance. Now this is the first question he has put in this book, that treatise he wrote called Optic, in which he summarized most of the optical thing what we study and teach our student. Okay. So the question was like this, that there is a star here and there is a ray of light passing close to it, and then he asked this question, that can the light of the star be bent by the sun, or gravity of the sun? And Einstein gave this general theory of relativity and proposed in 1915 that answer to this question should be yes. How to test this hypothesis? So, Arthur Eddington, here is Arthur Eddington and Einstein. So Arthur Eddington took a mission to away from to take a mission in 1990 to find the total solar eclipse which was visible from southern hemisphere. And what he did was he took a picture of the sun as well as the background stars. And here are the stars here. There are stars which are placed. And what he did was he took the picture of the sky beforehand where the eclipse was going to take place and after the eclipse, and he found that there was actually the right amount of displacement which was predicted by Einstein, and this was considered as a major success to prove that Einstein's theory of relativity or general theory of relativity. So that was interesting. Now comes the another interesting part about these occultations and eclipses and transits is that you know that in 1600s when Galilei first saw Jupiter, he saw the moons of Jupiter. But when he looked at Saturn through his telescope, he was unable to identify, make out what that Saturn is, because through his primitive telescope it looked that there is one ball in the center and two satellites next to it. And after some time the satellites themselves vanished. So what has happened, he was unable to understand, and only later on when Huygens, Huygens eyepiece that you use in your laboratory is the same Christian Huygens. He found out, he made a better quality telescope and found out that this planet Saturn has rings around it. Now, the rings are there, then the question comes, what these rings are made up of? Then Max Planck came up with a mathematical theory. He said that this ring cannot be made up of a solid disk, but it has to be made up of a large number of particles. If you put a solid disk around the planet, then that disk would get integrated very fast, and you will be left with small particles. And this is exactly what was observed later on by two amateur astronomers, when the Saturn passed in front of a bright star, and the star was seen through the rings. Actually, on the this occultation, I will also tell you that in 1970, 79 or so, I don't recollect the date exactly, but at that time, Uranus actually passed in front of the star, and people were eagerly waiting to observe this. This particular observation was taken not too far from your place, maybe about couple of 200 to 300 kilometers. It was this observation. These observations were carried out from Kanpur Observatory, and they pointed telescope to this particular star in front of which the Uranus was going to pass. And well before Uranus was occulted, well before Uranus occulted the star, prior to that, actually the starlight completely dimmed and became bright. And they thought first that there is an instrumentation malfunction, but it was not instrumental malfunction. This happened because there is a ring around Uranus, and it was considered one of the major discoveries of that era. So rings of Uranus were first find out by the occultation method. Now, occultation method also would show you that this is the moon. Moon also occults the different planets. Okay, this is a particular beautiful occultation of Saturn with by the moon, and here is another picture where the Saturn is coming out from behind the moon. So this is this arc is the dark region of moon, and such observations are on number of times used to find out, because Saturn's brightness would not allow you to see this edge region, but when there is an occultation you might be able to see that. So such occultations are used. Now another interesting occultation which I would like to talk to you before I close my session, and that is moon repeatedly occults a very bright star. I mean, many bright objects it occult, and if some of you might recollect that very recently on 5th of February, moon occulted a bright star in the constellation of Scorpius, the Antares or Jeshta star. Okay, it's a moon occulted that. So the moon came directly in between that star and us. Now, there is a very interesting story about it. This is another picture which shows that the moon is proceeding. So this observer A sees the star separately, whereas this observer B, this star has been already occulted. Now, this method can be used for finding the angular size of the moon. Now, how it is done? So, there is a little history also. So, in 1905, one army major he proposed that if you during the occultation event, if you take a continuous picture of the star being occulted, then what will happen is that over a duration of time, okay, the star will become faint and faint and it will get vanished, and so you can find the angular size of the star. Now, why angular size of the star is important is why angular size of the star is important because if you know the distance to the star, then by knowing angular size, you can find out the actual size of that particular star. So there's a lot of efforts being carried out by people. The Arthur Eddington, who has been also responsible for downgrading Chandrasekhar, he killed this particular idea and he said that during the occultation, when the star is occulted by the moon, it will give you the Fraunhofer fringes, that is, you have a bright and dark fringes, which you can actually see in the laboratory, that when you have a point source or small slit source, and then you cut with a sharp blade, then you can see the bright and dark fringes. So he said that during this fringes will be seen and we will not be able to make out. But then about 50 years later, the electronics had become great, electronics developed, and some engineering students, they actually use this particular phenomena of the fringes to find the angular sizes of the star. Now this is what happens here. This is your telescope. There is a star there, which is we are looking for the star, and then this is the motion of lunar shadow. So as the lunar shadow, the star being occulted, you have this bright and dark fringes, and when it is occulted, so you take a trace like this, and you can find out by measuring this size, you can find out the angular size of the angular size of the star. Now this is of course wavelength phenomena, that is you need to have a particular wavelength. If it is a white light, it will get merged, which he did not talk about, but anyway, but a lot of people have started using the occultation method to find out the angular sizes of the moon. Here, another interesting historical episode which I would like to narrate to you, that not again, even lesser distance than Kavlo rays, is that not very close to you is Hooty radio telescope. And Professor Vijay Kapahi, who went on to become director of Giant Meter Wave Radio Telescope, and poor fellow, he died much too younger, before his 60s. So he had proposed to find the occultation phenomena, to find the positions of galaxies using Hooty radio telescope. And for some period of time, those were the best positions of the galaxies as were measured from the Earth. So occultations have played a good lot of role. This is one graph, but another interesting thing about the occultation is that sometimes if the star is binary, that is, there are two stars, then you don't see, you see not just one dip, but you see one dip and another dip. And now you see how much is the difference. It is just about 50-70 milliseconds. So when the event takes place and you take a trace, one event and another event follows one after the other. So you can find out by occultation method if the star is binary or not. So this method is used by professional astronomers. Now towards I'm closer to the I have exceeded my time, but let me also tell you a very interesting eclipse observation. Actually, eclipse and occultation observation. There is a star called Algol in the sky, and this is the particular phenomena which you can share with your student and you can observe. This is a beautiful phenomena. Now, this is a star in the constellation of Perseus called Algol. Okay, and its brightness is approximately it's about 2.1 magnitude, and then the star fades to fades by nearly 1 magnitude. What is happening is as follows: that if you look at the star and take its brightness, then it becomes dim, then it rises again, and then again it becomes dim and rises again. And what we see is this, that we do not see the companion star. These two, okay, this is the same star on the other side. So these two stars, we do not see them separately, but the light of this star keeps fluctuating. So when both the stars are away from each other, then you have this flat curve. Then, when the brighter star is blocked by the fainter one, you have a deeper drop in the light, and when it is behind, you have a shallow dip. Now, this can be very easily observed in the sky, and I will share with you, those of you who can write to me, I will share with you the types of eclipses of Algol. Okay, we still call them eclipses of Algol. So you can see the eclipse, and all it takes is approximately 5 hours to star to become faint, and in another 5 hours for star to become bright. Okay, so this is a wonderful phenomena which you can do. Now, this is a little old story long ago. This story is there are a lot of asteroids and minor bodies in our solar system, hyperbelt objects. And they're so far away that you see them as a star. Like in fact, asteroid itself means aster is a star, so star-like object is asteroid. Now this asteroid was predicted to pass over India, and some of us will travel some distance to actually observe this occultation. What is occultation? Well, this is the occultation of path, and we came somewhere here, and this is our small team. It was taken long ago. I am looking very young, and this is a young team. And we brought that, we took the telescope, and everything was, except for the telescope, everything was homemade. We went to Ganesh Gudi, and there were other observers from different parts. That is the Vinobapu Observatory at Kaulur, and these occultations were observed. Now, what is done in this occultation is that you keep looking at the star. You possibly may not even see the asteroid, okay? But then at the time, the light level of that star will dip, and then it will become bright again. So the duration of that dip and becoming bright will give you chord, and if you have more than 3 observation, then you can actually fit the ellipse. With this particular kind of observation, again you can do it with the help of your students. Actually, the lunar occultations and asteroid occultations, you can do it. They are actually doable with the naked eye and the stopwatches. So you can do this occultation and contribute to the science as astronomy. So as far as your curriculum or college activity is concerned, you have a chance to significantly contribute or in that particular era in the astronomical studies. And what we had done is we had done very nothing. We just took one webcam, and taking the webcam, we removed its lens and put it behind the telescope here like this, and simply watched on our computer screen, and we saw the occultation. The other last thing I would, before I end, I just want to tell you that this is the Jupiter's images. And sometimes you see the moons of Jupiter crossing over its surface of Jupiter. Sometimes moons of Jupiter get occult each other, as I told you right in the beginning, occult each other, and they eclipse each other. Now, how to find the speed of light? So there is a beautiful way that by actually timing the occultation and eclipses phenomena of Jupiter, you can find the speed of light. But since I have rather overshot my period, so let me just stop here, and if you have any questions, or any comment, I'll be very happy to answer those. So let me just get back to the screen. Thank you very much. I'm sorry I did not go into deep. I had to really rush through, but some other time we can certainly meet and discuss this. Thank you very much.
Whether any questions? Somebody?
I can also understand that people are tired and want to go home too. So uh, he has my email ID. We also publish one small newsletter for 24th of sorry, for next month newsletter is out. So you can take my his email ID from him. It is also given on the WhatsApp. So I'll be very happy to share with you. In fact, latest one I will share with you on WhatsApp.
So, any questions? Okay. So I think at present they have no questions. They will be asking you in WhatsApp, and you also have to go. So anyway, thank you so much that you. I know that you are very busy. Means you are in a urgent condition. His wife is hospitalized. She is undergoing some treatment. So thank you so much that you spared in this moment also some time for us and spoke to us and shared your things. Thank you very
My
much.
pleasure. My pleasure. My apologies to all the participants. I want to just thank you for listening to me, and I tell you that I did not really do a good job of it. I should have gone step by step and explained few more things, but some other time. Thank you very much.
Thank you.
Thank you.
So, well, we will stop for some 10 minutes. You can go to your work or drink water or come back, and then we'll go for the next. അത് ചെയ്യാൻ മുന്നേ എല്ലാവരും നന്നായി സർവേടെ പോലെ പോസ്റ്റ് അത് ചെയ്യാം അപ്പൊ പോസ്റ്റ് അത് ചെയ്തിട്ട് Those who have finished the solar system, you can try this occultation now. It is nothing but you have to take the foam board of 4 inches and double it, and you can make a rectangular liner like this. You can make holes, 2 lines, take 2 sticks, in one put one small disc, another put one big disc. The big disc represents the moon, the small disc represents the sky. Now if you move this big disc along each of these holes, you can see that at certain point it covers and then it comes out. So this phenomena is called occultation. In this way you can demonstrate some occultation. Now if you interchange the big disc in the back side and front disc in the front side, then you will illustrate the transit phenomenon. Transit is like Venus and Mercury moving on the disk of the sun. So that is called a transit. Or satellite of Jupiter moving in front of the disk of the sun. Shadow transit of satellites of Jupiter. So both this phenomenon, occultation and transit, can be explained in this model. If you want to make this model, you can also try. You can take a knife and cut the 4 inch. It will take just 15 minutes. This takes time, which will do. That doesn't take time. I don't have water item. Crayons. You can, I think, just use. Take small, yeah. So maybe single one there will be, but that of the center will be difficult. So maybe with a knife with scissors you have to postpone it. So otherwise you have to do it small stick. Small stick is also small. Take smaller. Yeah, first slot is interchanging. First slot is the operation of reverse slot is continuous. So feedback is now I get മൈക്കൊക്കെ ഓണാക്കാം. പിന്നെ ലൈറ്റ് ഓണാക്കി, പ്രൊജക്ടറൊക്കെ ഓണാക്കി. ഇത് വെച്ചോ ഈ ലൈറ്റ് ഓൺ ചെയ്യും ഈ മൈക്ക് വെച്ചോ
Hello, hello.
എല്ലാ ടേബിളിലും അവർക്ക് വേറൊരു ആളുണ്ട് നിങ്ങൾക്ക് തീർച്ചയായിട്ട്
Hello, hello.
Yeah, good evening. Yes. Good evening.
Can you hear me? I can't hear you.
I can hear you, but I don't know, Vinod. Vinod, അവിടെ കേൾക്കാനില്ല. Just a minute. Hello. Can you hear me? Can you hear me? Can you hear me? No. No.
Wait. Can you speak up?
Hello. Can you hear me?
Now I can
Okay.
hear you. Yeah, there was some problem on my side. Stuck.
Yeah. So we will start. I think let us wait for Neil and Anita also.
Sure. Yeah.
So actually, in these 3 days, they enjoyed. Most of them, they were there. But in late night session, one day only the observation day they stay. Other days, many who have faith, they have to, they
Yeah,
have
of
to,
course.
those candidates, they have to reach back home and they don't
Yeah.
have wait from their railway station. So we can't also make them wait so that they can't
No,
also.
yeah, sure.
Yeah.
Yeah. No, we had similar problems in Pune too. So, yeah, no, I can
So
empathize.
that way we have something. And most of these every speaker came except that Tusat Titus, Dr. Titus, his daughter is admitted to hospital, so he had to go to Vijayawada. So we have
I see.
replaced with Dr. Anandita Mandal from Nehru Science Center, Mumbai, who spoke
Okay.
on binary stars and variable stars. So that was a cosmology we could not discuss this one.
Okay.
And we have also discussed about a lot of pedagogical things about how to present solar system, because this is one chapter which is mostly present in all our school syllabus.
Textbooks.
School syllabus. So we have one video in which actually you can see that we have recorded all these sessions. No? I will be uploading in YouTube and I will show you. We have discussed the various ways in which solar system can be actually delivered to the students, and they have suggested a lot of things, and I myself have suggested. We have not discussed elaborately on solar system as such, though there was a session, but we dedicated. I thought that it would be much beneficial. The way of teaching, if we can discuss something more than actual stuff,
Yes.
stuff they can get it from the many sources. But
Indeed, indeed. Yeah.
so
Yeah.
that was one thing, and
So how many in total finally could join the
actually,
program?
it is variable. 30% were there at last in first day. Then, but
Okay.
in evening it dropped, and next day some 26 were there. And
Okay.
today we have in morning 23%. But then in evening, many wanted to go, and they said that we have every day we are getting late and all.
Yeah,
I
yeah.
said that the certificate you will get only if you stay up till late. So they said, no, we will collect it afterwards. So ultimately,
Yeah.
no, we have to.
No, I understand. I understand. It can be difficult, so yeah, that should be fine.
And today we had model making session in astronomy, and I think,
Okay.
yeah, where they enjoyed doing models, and I think few of us can just display your model. No? You can display
Oh.
afterwards also, but again, can some of you just show your models what you have done? Some of you just come forward and show it, whatever you have done. So it may not be very best, we do understand that within 1 hour or 2 hours you can't do the best of the models. But anyway, what you have done, you can just show it to him. No, he will see. I think you can come here near the camera. Camera.
Yeah.
Yeah. You can come nearby, both of you. Those are both together in group. You can come.
Oh.
That is wonderful. No, you have come here.
You can see some solar system.
Yeah. All of them two things, solar system and transit occultation model. But solar system only what they work full day with 1 hour. So that took lot of time. You can
Yes,
hold it
yes.
properly towards the camera. Can you
Oh,
bring it a little
excellent.
closer? Can you take it a little closer?
So these are like two scale,
Yeah, they are
like
scale
images.
pictures. And the distances also I told them to take in some scale proportion. We gave it in astronomical units. So I said that it should not take some random distance somewhere. Average weighted the
That's
distance from the
perfect.
sun. And the size is also taken Earth as a unit. They have scaled the other planets. And so I said that this should be something different from what is normally commercially available, that they put all the things one after one and they take a photograph and they print it up.
Yes.
Yeah. So
Yes. Yeah, we also did a similar exercise, but not so colorful, with the teachers in Pune.
yeah.
That's excellent.
Is there anybody else? Can you just show somebody who has completed somewhat? Yeah. Can you come? Yeah. You can also show.
Oh, that's wonderful.
Yeah.
Excellent.
Yeah.
Yeah. Sizes are really appropriately scaled. Yeah.
Yeah, you can just come with that model that is somewhat different. Yes. So you have also made solar system. I know. So this is what is the transit occultation type. So you
Yes,
put it
yes,
in
yes.
reverse order. You can just put
Uh-huh.
run. So this becomes an occultation model. So no,
Yes.
no. What he has done is correct. You have put it in opposite direction. What you have done is like this. And maybe this moon this is a star representing some star, and this I said that you put a series of holes so that you can show that sync is coming and occulting, and ultimately
Yes.
it will be fluid. That's
Yeah, yeah,
the
yeah.
camera. So it will actually it is something like this. If they go on putting in one hole, and ultimately it will traverse and it will block for a certain duration of time. So
Yes,
that
yes,
is the
yes.
phenomenon of occultation. So this is
Excellent.
something they have
Yeah.
done. And they also visited our astronomy gallery. I think many people are, they will show you. That everybody is
Yes.
getting ready. And they have also done, they visited our astronomy gallery and interacted with all the exhibits. So that was there in today's morning. And of course, lectures and other things all happened. Yesterday we had an observation session. Initially it was cloudy, but then moon and Jupiter and all those things they saw. Orion constellation they understood. They saw.
Oh, right.
So all those things.
Yeah,
That's
it's
quite
quite
beautiful.
beautiful, of
Yeah.
course. Yeah.
And I think now some students, some of our teacher members can speak something. Uh, should we, I think Neeraj, should I call him?
Sure, yeah. You can check with Neeraj if he is around. Otherwise, yeah. It can be getting late for also those participants again. So,
That's right. Hi, good evening, Neeraj. So, Aniket will not be able to join us. He is in some other meeting. And so we will, I think, no, we will start the last thing.
sure, sure.
Yeah. So, well, one by one, can all of you just come and share your this one? Somebody can start. Somebody has to start. All of you speak something. This is the time you have to say what you have. Yeah, yeah. I think camera can be turned with. That.
കുറച്ചൊരു ഫ്രണ്ടിലേക്ക് നിന്നോ കുറച്ച് ഫ്രണ്ട്
This is the audience. So you can do one thing, camera can how long is that wire?
ഇത്രയല്ലേ കിട്ടും
Can
കുറച്ച്
you bring it little this side? Not that side. watching, not the audience. The TV will be facing the audience. Now you can. Take it back. Okay.
Hello all. So I'm Ajmal. I have been teaching in college level mainly the past 2 years, and I was working as a engineering physics faculty, and now I am currently doing my PhD part time, and also I'm doing I'm collaborating with one of the industries that is related to education, and I'm working on the science communication side. So I don't know where I belong to. I'm currently in between a phase in between academia and industry and science communication. Like it's in a hybridized state. So so my credentials are very. But the thing is that like why I came to this program is because during my college days, like I thought of taking physics during my 8th or 9th, and I was into physics because of astronomy. And later, when I applied to programs, I did not get much exposure in the domain of astronomy, and like on the contrary, I work mainly on the quantum mechanics side where in astronomy it's in the order of 10 raised to 30 and all, and the domain that I'm working on is of the order of 10 raised to minus 10 or minus 6. But the thing is that my passion towards science was mainly because of astronomy. So, like to spread more science and like my primary interest, like the initial interest in astronomy is still it's there. So I want to spread that to the community, and that's why I came to this program. And on the program perspective, I think uh, so for students, the technical session may not be very helpful. Like we don't have to know the like core research field to be an amateur astronomer or a science popularizer. So the thing is that this program had a balance between both technical side, which fascinates me as a researcher. On the other hand, there were a lot of sessions which I usually don't take part in because I'm more of a technical guy. But like whatever we did, the model making or like where we did this divergence session and all those things, it was very interesting, and it is something that we can use to bring attention. Like rather than showing very big mathematical equations on black holes or singularity or something like that, it's better to show an image of a black hole or galaxies or anything. So this program was very fruitful to me as a researcher and as someone who likes to communicate science. So it was very nice. One suggestion that I have is that we have to like we can include session like the Homi Baba Center for Science Science Education Research. Like there was someone who was part of that in the inaugural. Right? Yeah. So they are doing very good research. I have actually participated in a program by them on mathematical modeling. So like how scientists like in that particular thing, it will have a method how mathematical equations come. So the thing is that we could actually integrate those kind of things, like how, like why do we need to do these rigorous mathematics, or how do these things come about, like without showing like complex equations initially. If we try to bring the math in a very systematic way to students, even that I think students can appreciate. And like those kind of sessions can also be planned, as we already have connection with Homi Baba Center for Science research. So that's one thing that can be added. Apart from that, it was very nice. And like sadly, Titus are from Busan. Like that session was missed, and I'm sad because I am very interested in this field of research. But like anyway, I wish everyone a good science career ahead of you. And thank you for hosting, like whoever were the brains behind this and all the organizations. I thank everyone who were present online and offline. And I look forward to events like this in the future. I hope I visit you people again. And like how actually Jayan sir shared in the Astro community, and that's how I came to know about this program. So thank you, Jayan sir, for sharing in the Astro community. Yeah, thank you everyone. It was very nice meeting you all and collaborating. Yeah.
Okay, thank you. So, somebody else? Next. One by one, all of you should speak something. Yeah? That is what at least whoever is present now. Okay, somebody else can just volunteer instead of my picking out somebody and telling. Anything. You can speak in, you may not speak very elaborately also. Say something which you liked. Can you speak something?
Hi all, myself Brigida, faculty in Baladev Devan School, Perindalti. First of all, let me thank the coordinators of this event. Actually, as a science teacher, we could enjoy all the moments in this training. Apart from the conventional training program, this session fruitfully presented. We got many chances to experience astronomy. Basically, I am a chemistry teacher. When we deal chemistry topics in class, one of the challenge we face is that to inculcate a kind of scientific temper in students. Actually, at present, I think, I don't know whether it is due to the order of technology or something else. I have a feeling that students are not that much. Actually, a kind of scientific temper, a kind of what I call, I don't know, that is missing in students. So, what I feel is we need something more to encourage them to do something more. So this kind of workshops, actually, what I feel is that we should do something more, something related with activity based. As CBSE said, CBSE, the new policy, National Education Policy, NEP 2020, it focuses mainly on experiential learning, activity-oriented learning. So what I feel is that we should focus on that. Activity-based studies, we should focus on that. So this kind of workshops really fruitful to us teachers. I will do my level best to carry the message that I got from this workshop. Then definitely all the lectures, all the sky watching, the astronomy lab visit, everything, each and every. These 3 days we all, I can say, we enjoyed each and every moment. We could experience the heartfelt, sincere work behind this workshop. We experienced that. So that I thank each and everyone who worked behind this. Of course, all. Thank you all.
Good. So, somebody else?
Hi, myself, Mohammed Shaki. I am a BEd student actually. So first of all, I am giving a thank to James sir because when I came to my university, I am a BEd student at Gandhigram Road Institute, Tamil Nadu. So after some examination, I just came to my home for a separate. That time I just see this program poster in one of the physics science period group. So I just Google and take the Google form for the filling. That time most of the questions were the school teachers. So I just made to Jack sir how if the teachers writing stories can be about this. So he allowed that. That's why I get this great opportunity. So and also the thing is when I made post graduation from in MSc Physics from CUJ. That time I had a paper or one paper is space physics and plasma physics. So that time the most of the concepts are like ionosphere, manosphere, and solar wind and something. That kind of all the paper and all the concept that we are seeing and we are taught like a is a like a theory paper. So there is no demonstration and no ICT presentation. That time we felt like it is a hectic situation. So we cannot also imagine what is the solar. So that way we can only understand the only the power. So by this program, I get the opportunity how the solar exactly works. So this program also based on the full topic, almost all topic covered the astronomy because I had a great like to study astronomy because if I am watching any movie in a Hollywood or something, I am only searching for the astronomy film because I am only interested in only that. So when I see the most of the movies, okay, my field will be astronomy. But when the experts say that the first guy, it is same. When we are going to the deep of the astronomy, there will be mathematics and quantum mechanics. That thing I have, we are going to continue with that. But I continue with my passion to observe the sky and other things and new updates about the astronomy. And it is one of the, it is the first my experience to get a sky watch in my life. As soon as I get the opportunity to watch the sky as a Jupiter also. So I would like to give thank you to all the staff members on here in Planetarium because everyone just behaved as a friendly man. So I really enjoy that. In a 3 day, we know that it's from 9:30 to 8:30. It's also a hectic period of time, but we are enjoying all the things and the demonstration and all the situation. My suggestion for this program is not much too much, but something also there because we are going to teach the students from most of the teachers will be going to high school and they are high secondary because the paper will be there and I think in the 6th standard will be there in astronomy subject. But the student mind will be the cognitive level, like their cognitive level like that because they don't have to think about too much about the astronomy. So we have to explore their mind, like we have to make a curiosity on their mind. So the most of the some section of this program will be based on the some research paper and the high like the PhD conference and thesis submission like the paper. But it's also good for us as a teachers because we get some ideas about that also. So if you are if for the next year or something some next year will be happening this kind of program will be happening here. So the organization committee will be made to some new methods how to implement the more techniques in the school education system. So that will be better for the teachers will be also. So once again I give the thank you for the overview. Thank you.
Yeah. Next.
Hi, I'm also a student from Gandhigram University, Rumaiza, first year student of B.Ed. I'm very happy to stand here after getting this 3-day training program. I was only because of for getting information more about moon, I came here. I like to learn about moon, and I always like to read about moon more. So getting more information about moon, I actually came here. But this made me confident enough to give someone some information about the solar system or Earth or more about the solar system, moon, everything. It made me confident to give information to someone, and I'm very happy that I got many opportunity like as he said, sky watching. It was very interesting. And if someone asks me about something related to solar system, now I'm ready and I'm very happy. I will be very happy giving them information. And this program gave me confidence to give someone the information about it, and I'm thinking how to learn more about it. This program gave me spark in many fields related to this, and I was having interest in many of the fields to read more and to get information. I think this programs like this will definitely help if you are concentrating more on teachers and giving such this type of classes. This will give definitely this will give a great impact for improving or coming the students to have more interest in this field. I think this program, I don't know who is taking more for this. This program is definitely will be a very good step in the education or in this field for the development of the this field in our nation, for getting more contribution or interest from our students. Focusing the teachers and giving them more information about this will definitely give a very good impact or effect, I think. And here the staffs and all the members are very supportive and very friendly, and everything. The facilities were all very nice, and for 3 days it was very good and interesting program for us. And I'm thanking from my bottom of the heart very thankfully all the staffs who gave this wonderful opportunity for us. Thank you.
Okay, thank you. Next, somebody. Come.
Hello everyone, I'm Risha. So just like everyone said, these 3 days were really good. After this, we'll be going to, means almost everyone will be going to the school teaching students. So in every class there will be almost 35 to 40 students, and each of them will be different. So to introduce a topic or to make them understand a topic, it will have to be approached in many different ways, because each one will understand it in different ways. So for someone to do that, first the one who teaches, that is teachers, should have a concrete idea about what they are teaching. Only then it can be approached in many ways. So from here, we have got that idea. For me, I have never been near a telescope. So now I can at least tell my students that yes, I have seen that things work in this way. What all things can be seen through it. That is what is the size of it. All that I can tell them. Then I have seen in many films, only films about. I have seen when people go on treasure hunt and all, they see map. They refer about some spears and all. I have come to this planetarium many times. I have seen in the gallery things like that, 3 circles, background there are stars, many markings are done on that, but I have never understood what it was. From Jensen's class, I got an idea about what that is. In future, when I see such a thing, I know what it is, and I'll be able to maybe tell someone about it also. Apart from all the theory classes, practical classes were also very good. Usually teachers do get classes each year from schools in the name of cluster classes, but for high school classes there are usually no practical works done. They are all mainly for primary levels. But now the high school teachers has also got a chance to make models and all. And in this age of audio, we have many aids, that is internet, students can search everything. We also, for convenience, make them watch videos more than making models. We approach it, means it has been that we rely on audiovisual aids more than models. But coming here, making models, our mind has also has made in such a way that we can also do models like that. Apart from that, about the food, I have to definitely mention the food. They have never let us be hungry. Every time they have given us food, chai and all. So that was really good. And yeah, all the coordinators and everyone are really nice. They are very down to earth. Yes. Thank you for everything.
Please. Nothing? Wala something? Yeah, next.
Hello, my name is Pratija. I'm a BA student. I'm from Farooq Training College. So like, I think most of us will be having a very good childhood memories from this planetarium, right? Like, I'm from Kozhikode and I've been to this place for many times. But just like Prishana told, I've visited these halls for many times, but most of the time I just went through it, just pressed the buttons, like didn't know what it really was. And there was, I think it was all limited to these posters written over there. And like we had to read it and like we had to understand it. But today we had a great opportunity where Jain sir actually demonstrated and explained what it was, and the whole team, I must say. First of all, I'd like to thank the whole team for extending this program to the BA students too, because I think when I saw this poster, the first thing that like came to my mind was like, rather than glaring at the moon every day, just enjoying its beauty, it's better to know something about it, right? So I think these 3 days was really fruitful for me, because I don't think in science we are learning much about the universe, and social, of course, we are learning about it, but science I don't think we are learning much about it. But when I came to here, I must say that we can explain something. I got something. I'm not going with an empty hands. I've got a bag full of memories, and along with that, some knowledge I've gained from here. So along with that, I was also tense, worried about seeing that brochure, like where there were theory classes. And along with that, what encouraged me to come into the section was like there were demonstration sections and activity sections too. Like yesterday, Lechi ma'am took out had an activity section. Like we had to explain the eclipses, right? So I think that was much incorporated with the pedagogical analysis aspect too, because I think these topics are being taught in the primary classes, right? So it has helped us to incorporate these kinds of things to students too. I mean, we can apply it in the schools, right? That's all. I mean, at last but not the least, I would like to thank all the faculty members and everyone who has been with us all these 3 days, have helped us in all the aspects. And thank you so much. And thank you so much, sir. Thank you.
Right. Yeah. Can you speak something?
Hi, my name is Mohammed Faslan. I'm from Farooq Training College. So the 3-day session is almost completed. I'm really going to miss this 3 days because it was really informative, and we all know that students nowadays are really smarter, so they will be asking so much questions. Sometimes we will be struggling to answer some of them. So to answer them, to implement all that things we learn from here, we should be uh, able to tell. So what we learned from here is really informative, and as teachers, we should be able to introduce the basics of astronomy from lower standards itself. Because I'm a chemistry student, and when we teach atom models, we base of it with solar system. Like an atom has a nucleus, likewise our solar system has sun. So it will be easy for them to relate some concepts in science with astronomy. So if we taught students from lower class the basics of astronomy, it will really help them and their thinking capacity to relate some of the scientific concepts with others. So, what should I say? The whole session was really nice, and some of the sessions were really good that I thought if it were to, if it were more, if it had some more duration, we learned so many things, and they gave us a notepad which is almost full because I was noting everything I don't know, so it's almost full. So overall, a good experience, and we learned to create models from which we can see the basics of astronomy, solar system to children's minds. So everything was simply marvelous, and I really enjoyed these 3 days. Thank you for every person who made this program success. Thank you.
Anybody else would like to speak? So, would you like to say something, sir? Regarding this? Whatever you have
Yeah, sure. So it was really good to hear all the feedback, and it's always encouraging to see that the workshops that we are conducting, they are being received in a positive manner. And of course, as we said, like it's also a learning experience for us at times, and so the feedback that you give is very important. I want to thank you also for running this pre and post surveys that we had conducted, because as I mentioned, we would like to know what kind of knowledge or mental beliefs that you came with, and then after the workshops, how they have been molded, and whether there has been a change in terms of your interpretations and your understanding or not. That definitely helps us to do these things better and better. I also would like to encourage, like I heard someone say that we would like to hear also about some more basic materials. So at Ayuka, when we conducted the workshop, we also have recorded these videos. We will be making them available, things related to phases, eclipses, tides. These are topics which are always present in some form or the other in science or geography curricula. So you can also take a look at our material too. I will post it in the group. We would be very happy to also take a look at the material that was presented at Calcutta and make it available to the teachers who came to the workshop in Pune. Because what we would like to do is to act as a place which can create and generate these kind of networks of teachers who can tell about ideas that they have been implementing in the class, and things that they have been doing, so that you can basically act as an inspiration for other teachers too, and learn from each other, right? So that is exactly our goal. We hope that this workshop has seeded that enthusiasm, and as someone said, that they have seen through the telescope for the first time, and these kind of experiences stick with you. and it also breaks down these preconceived notions that we have about what we should observe when we see through a telescope. Because oftentimes in the media you just see these big and beautiful pictures, but when you actually see it through a telescope, you see what it looks like and all the things that are possible through it. So I'm really glad that somebody could actually host this workshop, and Neeraj as well for helping out with the organization and the scheduling of things. And we hope you can inspire little minds and nudge them to use the beauty of astronomy to get them into sciences, get them interested in science. And some of them maybe will become experts in astronomy, we hope. And also maybe some of them will get inspired to do all these missions that India is launching. So thank you so much, and please keep telling your stories within the group so that we can also tell them to others. Thank you. Thanks.
But one thing, what I think that you have given the pre-test and post-test. What I feel is that the questions, though the topics may be same, the things may be same, but questions if they are varied in both the tests, that would be more. I thought that most of the questions are repeated.
Actually we repeat all of them. Because see, what we have seen is, let me clarify that. What we have seen is, there were a lot of incorrect answers even in the pre-survey. So our try or what our hope is that some of these things actually we see the improvement or not. Okay, and that's the reason why we have kept the questions to be exactly the same. We want to see whether some of these misconceptions that are present they get addressed or not. Right, and so that's the main reason. Like we did it in also the Pune workshop, and now we are doing it in Calicut. And of course, all the time we are seeing that there is a positive movement, which is great. But I did share the results before with you, just so that you guys understand that like things which may seem obvious to people who have been in astronomy for such a long time, they may not be obvious for even teachers. And if teachers have some misconceptions, they also get propagated to the students. And so we are trying to see just within those known questions whether things improve or not.
Yeah, but one suggestion is that either you change the wording or means in a different way you ask the same question, or maybe because you are seeing the improvement, but it may not reflect the conceptual improvement, it may just reflect the factual improvement. And then they have made some wrong answer and now they will discuss among themselves, oh that was not correct, so this is correct. So that doesn't show that they have made a conceptual improvement in that. That shows that.
That's the difficult part. I mean, what we like is of course to encourage all this kind of talking to each other to figure out like what may be going on, why some of these answers may be incorrect. Because the questions that we designed try to get them a little bit get any differences that happen. The other thing that we want to do from a research perspective is wherever there are wrong answers that were given, we would like to interview some of the teachers or even the right answers that were given. I would like to interview some of these teachers to figure out the mental models which are there in their understanding, so that we ourselves also understand when we design these courses as to what are the misconceptions that are present, because there are variety of things that we may not even have thought about that people build these mental models of and carry with them for like many years until it gets questioned. So we are also learning, of course, and we'll be doing these kind of changes too. Indeed.
Okay, thank you. So, yeah, next Neeraj, do you like to speak something?
So it looks like it was a fantastic workshop, and I'm really sorry I couldn't be there with you. Hearing some of the feedback, it looks like the topics as well as the way it was taught resonated a lot with the teachers here. Especially, I realize a lot of chemistry teachers here, and I'm happy that the chemistry teachers also got something out of this and could relate to a lot of things which were taught here. Somebody also mentioned scientific temper and how knowing, how inquiring about such basic topics in astronomy which we see around us helps the scientific temper. I think that's really important point. I think a lot of hands-on exercises were also very useful, and I think PR Lakshmi from the planetarium was there, and I'm really thankful that she was able to go and spend time with everybody there. I think a lot of topics which were introduced in this workshop are different from what the students might usually ask you. Students usually ask us questions about black holes and Big Bang and exoplanets and so on. But as we talk about the phase of the moon and tides and the solar rotation and things like that, but I think there's a strong purpose behind that, which is that though we all fascinated by things like black holes and Big Bang, the astronomy which actually intrudes upon our daily life, or we engage with in our daily life in various ways, are the sun and the moon and day and night and the phase of the moon and the calendar and tides if you're living near the sea and so on. And therefore, it's important that the parts of astronomy which actually engage, which actually like engage, which actually like we need to mute. Yeah. So I think it's really important that the topics of astronomy, which are not seen as glamorous, but actually are things we face day in and day out, like calendars, religious festivals, and so on, are talked about and understood very well, because that again goes towards promoting scientific temper in a large way. And I think very importantly, we need to take this forward. And I know you said it's a WhatsApp group, so I think that's a very good thing. All of us are in the WhatsApp group, so we can keep discussing there. And more importantly, the idea is not that all of you here come back for another workshop, but the idea is that all of you go and teach other workshops hereafter, right? There'll be 20 people here, so there'll be 20 workshops in the coming months, and I think that's the important thing, and I hope that really happens. Lastly, somebody mentioned the lunch was really good. I'm very sorry to miss miss really good food in Kozhikode. I like the food a lot. I've been there before, but that will be repaired next time. So I think thanks to all the organizers and all the people who have come to Calicut and helped organize all of this. And I hope to see all of you in Bangalore at some point, or maybe I'll just come there for your lunch one more. Thank you.
So, Nanaji, do you want to speak something? No? Then camera can.
So thank you for your nice feedback, and I hope you will continue the same work. Don't stop your work here, and whatever stuff you have got, whether it is written or online or physical, and the models also, you just carry on. And as someone has said, we have missed taking the career in astronomy. So for observing or becoming an expert in astronomy, only thing you need is a night sky, clear night sky, and the curiosity for observing the sky. So if both these things are there, even at your school also you can inspire a lot of children. And the group is created, let be in that group. Don't think that after the program you simply left, because that group is for sharing your thoughts as well as our thoughts. And in future also, if any such kind of programs, if we are planning not only related to astronomy, even other programs also, because we came from different backgrounds. If we are supposed to organize some other kind of program related to your topic, so we can also participate in that also. And also, if you are doing any program related to astronomy at your school, and we can post those photos or information also in our group, so that we will be very happy that whatever the information or stuff you have carried from here, you are taking to your school. Okay, thank you.
Yeah, so now we will distribute the certificates in presence of everybody. I will call the names, and I think people can come and collect it here. Drisha. Nikesh. Then we can accept that. Hey, correct. He will come after Mohammed Shah. Rumaisa. Jesse Joseph. Intuja. Nahida P. Norman Parker. Nisita DC. Nisita DC. Pranjila M. And Krishna P. Okay. So remaining persons are not there. That we will be, if they come, we will give it to them in their hand. And in the conclusion phase, I would like to say that it was first of all I would like to thank the Office of Astronomy Education India Center. You have fully sponsored and generously given us the money for actually doing this workshop. And then all the works, I would also like to stand in this point, Dr. Neeraj Mohan, who has actually sat with me and in an online mode we have actually discussed and ultimately made the full proposal and how the mode of sequence of things should be there. So we all discussed and did that. So thank you for that. And then I would also like to thank all my colleagues and everybody who has actually given a lot of arrangement support. And because for smooth conducting of any workshop, we know that it can't be done on a single-handed basis. We have to do it in collaboration with many people. And the publicity was there and other supports were there for conducting this workshop. So as a whole, I think from the feedback and from the way we interacted with other people and the way we went outside and we actually went to another college to do our observation. We didn't do it in our center because first of all, our center is in the heart of the city now and it is highly light polluted. And secondly, that there are a lot of trees which has come up which in this 20, 30 years which I am here, I saw that a lot of trees coming up here. And you can't cut the trees also because that creates a lot of other issues. So trees are also there, we have also to stay, but then we went to a college which is in a high elevation area, it is in above a mountain top. So we got, but when we went there, we saw that there was a grass fire. So already some people have, the college authorities have called fire brigade to stop that fire. So I was thinking already, and it was cloudy. With cloudy smoke of fire, then I was thinking that what we will do with this full, we brought telescopes and all and we came here. Then ultimately, anyway, fire got off, the people went away and the cloud also cleared and at least for some hours we could observe the sky quite a good way. So in some total, making a summary of everything, everything went well and it was actually, I think, we have a good workshop and so we thank everyone one and all for being with us. Thank you very much. So we conclude here.
Thank you, Jay. See you.
Thank you. Thanks, everybody. Bye.